So that was our first little video. Now let's get acquainted with the tools that we will use in order to create these circuits. Basically what we're dealing with is a Raspberry Pico W. Why a W? Because that means it has Wi-Fi and we are able to use that Wi-Fi in very fun ways. Basically what a Raspberry Pico is, I'll keep it up closer to the camera like a real YouTuber. This little silver chip is the Wi-Fi chip. That is what causes it to be connected to the internet if we code it to do so. In the center, this little black dot is the actual Raspberry Pico. The green board around it is just to basically connect all of these pins on the outside. You can see a little bit if you keep it close enough. These wires coming out of the Raspberry Pico chip towards the pin. So we're basically just interacting with the chip. Everything else in the components over here are just to make sure that the power that goes through it is correct and that we can program it using an USB, stuff like that. So that is our core of the entire classroom. At the first few circuits, we will use it as a power source, but later on it will become much more. I have printed out a small schematic of the Raspberry Pico. I can advise you to do the same, because that basically means that you have always a reference of which pin is which. I will keep it up here for me to work with. So the first thing you will need to do is you will need to put your Raspberry into your breadboard. Why? This breadboard will make it way easier for us to work with the Raspberry Pico. How does it work? This breadboard is small. This is basically a small little copper channel in form of a V that runs through this breadboard, and every pin we plug in makes contact with it and the electricity can flow through these little gutters towards the other pins. That is what's happening. How are these connected? Here, the plus and the minus sign at the top, very important. These two rails run down. So the top one is connected to the bottom one, right? In the middle, that's the opposite direction. So the left one is connected to the right one, each in their own little row. So here we have two columns. On the other side, we also have two columns. And at the middle, we have small little rows of pins that are connected. What does this mean? If I plug something in here and I plug something in here, those two are connected. If I plug something in on the top right, next to the plus signal, and on the bottom, on the top left and on the bottom right, those two will not be connected, because in the middle there is a gap. This is just a small copper gutter that runs from top to bottom, and right next to it happens the same. Why is this plus and this minus symbol so important? That is because we will use that as a convention to make sure that we can easily work with these circuits. If you keep hustling them around and keeping the pluses, the minus, and vice versa, we will have issues and it will be very hard to keep everything in mind. Notice, everything in this course is about making it as easy as possible for yourself. The more you can do that, the more you can put your mind towards what you're actually doing. If you need to keep remembering, all right, I did plug the voltage into the minus, into the blue gutter, and the ground into the red one, or on the other side, or I will use a yellow wire for this now, I don't know, I can't find the other one. That makes it harder and harder to keep track of all of the little things that you tried to figure out. And that means that your circuit will be very hard to understand, not only for me, but also for you. For me, why? Because if you ask me to debug something, that is the first thing I will check. If you use the black wires for ground and the red for 5 voltage, which is the basics, which is what we always try to do, then that means it's easier for me to keep track of it. That's the first convention you will see. The black wires are always used for ground, and the red ones are for 3 volts. Why specifically 3 volts? Because we can program these pins to only spit out voltage every once in a while, whenever we want to, whenever another sensor is doing something. That doesn't matter. We need to stay, we need to know that every red wire just always has power. And that makes sense then later. First of all, I'm going to plug in the ground, which is the third, and I can immediately plug it into the blue line on the right, which means that all over this rail I do have power. And then I can do this, this is the ground, I do have a minus. And then in the fifth, 3 volt 3 out, I can put the red wire and plug that into the second. Right? So now the red one if you can see, the red one is connected to the red line and the black one is connected to the blue line, which means these two rails will have power if I plug this in. Right now we cannot see anything happening, but know that these are powered up. Always do this at the start of your circuit. This helps both to know that there is a power line that you can use, but also to basically keep track of, all right, I know that everything that is plugged in here has 3 volt and everything that's plugged in here has a ground connection. That makes it way easier for you to understand your own circuits. Just always start with this.